all know that exponential functions and logarithmic functions are inverses of each other?
Yeah, I know that.
They're inverses of each other. So that's why we're going to now go to logarithmic functions, because of that. Okay, so let's say we have okay, so what did I just write? What kind of form is that? This is exponential. So you need to know how to go from exponential to logarithmic form and vice versa. Okay, so the logarithmic form is the log of base x of y is equal to n, which is going to be the exponent. Okay, so we got exponential form and log form. Okay, example. So let's say we have 2 to the third power, we all know, is equal to 8. What is the logarithmic form of that exact equation? So the log of base 2 of 8 is equal to 3. Perfect. Okay. If I had the log of 8 equals x, let's see if I could throw this out there right away. What's the exponential form of this one?
8 to the 1 is x. 1 to the 6.
Did anybody notice I'm missing a number?
X equals 8.
Ah, okay. So when the base is not written, that doesn't mean there is no base, or it's even 1 for that matter. Okay, when there is no base that's written, it's in a base of 10. Okay, so if we know that the base is 10, what's the exponential form of this? Okay, yeah, I think you said that right. So I'm going to say 10 to the x is equal to 8. Okay. Okay, so this is what they're going to have you do. Evaluate. So let's say they give us a problem such as the log of base 3 of 81. So anybody know what the log of base 3 of 81 happens to be off the top of their head?
8, 6, 4.
Whoa, 97? 27. Nope. Okay, so obviously you guys don't think in logarithmic form. So let's convert it to exponential form and see if we can figure it out that way. Okay, so imagine that this was set equal to x, because that's what we're trying to figure out. And if we convert it into exponential form, what would that be? 3 to the x is equal to 81. So 3 to what power makes 81? Feel free to use your calculator if you must. 4. Okay, so how did you guys get those? Those of you that were using your calculator.
I took 3 times 3, 4 times.
So you guessed, right? Okay, so really at this point, that's the only method you know. You're going to guess and check until you figure out which exponent makes this true. Okay, so it is true that 3 to the 4th power is equal to 81. Let's do a harder one. Let's do the log of base 2 of 1/32. Okay, so how do I evaluate this? Okay, so we're going to start by setting it equal to x and converting it to exponential form. So that would be 2 to the x is equal to 1/32. Okay, so at this point, this requires us to know just a little bit about exponents and how we can make fractions and make things bigger and make things smaller. What kind of exponent do we need to have in order to make a fraction? A negative. Okay, so try some negative numbers. 2 to the negative what? 2 to the negative 5? Wow, that was fast. 2 to the negative 5 is right. Okay. You could also figure it out by just doing 2 to the 5th, and then just know that a negative exponent puts it down into the denominator. Okay. Should I keep going with these? You guys got this? Okay. All right, so the second part of this is knowing logarithmic properties. So these properties are, I would say they're not necessarily necessary for you to know. Like, if you know them, it makes your life easier. But they kind of, you know, you kind of go, oh yeah, I know that. Okay, so let's say we have the log of any base. Let's call the base b to the 1. Anybody happen to know the log of any base of 1 is? It's 0. Okay, because any number to the 0 power is 1. Okay, so that's the thought process behind that. B to the 0 power is always 1. Doesn't matter what number it is. Anything to the 0 power is 1.
So what does that have to do with it?
That's just a property. Just something to
So
know.
it's like 2 separate properties.
Well, I'm mostly just using the log property, but I'm explaining it with exponential because your brain works exponentially and not logarithmically.
So b to the 0 is the exponential form.
Yeah, of the other one, exactly. Okay, let's say you have the log of some base of the same number. Okay, it would be 1. Okay, so the idea of this one is b to the first power is b. That's the idea of that one.
Is that a 6 or a b?
It's a b. B. What's that?
Oh, so if they're the same number.
Right? If they're the same number. So if it said like the log of base 5 of 5, that would just be 1. Okay, so if they have the log of some base of b to the x, anybody know what that is equal to? Very good, it's equal to x. Okay, so if two things have the same base, that basically just tells us that the exponents must be the same too, right? Sure. How about if I have 2 to the 10th, and that's equal to 2 to the what? 2 to the 10th, right? Oh, if you had, well, that would be the log of base 2 of 2 to the 10th. That's what it would look like. So the 2's would go away and you would be equal to 10. Fourth property, if you have b to the log of base b of x. So this one is in exponential form, but the exponent of the b happens to be a log. Want to make a guess on that one? What's that?
That's what I call no.
Nope. You don't want to make a guess? Come on, make an educated guess. Throw something out. Okay, so this one would be if you put, so this is exponential form. If I put it into logarithmic form, it'd be the log of base b of whatever we're looking for. I'll just like hold in a space. Is equal to the log, bless you, base b of x. What's the missing space?
Whatever that value was equal to x.
So it's equal to x, exactly.
And so that space.
The space is representing what I'm trying to figure out what the number 4 is equal to. I didn't want to use another variable because I felt like that would be confusing. So, something you might see. You might see 3 to the log of base 3 of 1. What is that equal to?
Oh, it's 1.
It's 1. Yeah, it's just 1. Should I keep going with these properties? The log 10 to the 5th. Want to take a stab at that one? Five. Because what's the base when I don't write it? 10. Okay, so if I have a log of base 10 of 10, they cancel out and I'm left with what the exponent is. Awesome?
What is the log?
The inverse of an exponential function. Anybody remember anything about a natural log? It is a button on the calculator. What does the button say?
ln.
Isn't that silly? ln. Why do they use ln? I feel like it should be nl. Just to make things a little more confusing. It does have its own button. What do we know about natural log? What's so cool about it? Why does it have its own button? It is also the inverse of an exponential function. Specifically one. So, okay, so the thing about a natural log is it can only have one base. And the base is always the same no matter what. It's in a base of e. Very good. Always.
Wait, so the basis?
In a natural log? In a natural log, it's always e. Always e. And that's what makes it a natural log. If it has a base of e. That's it. Okay, so if I say y is equal to the natural log of x, which by the way is the logarithmic form, what's the exponential form? Close. Really close. e to the y is equal to x. Okay, so remember what we did up here at the very beginning? That conversion? Same exact thing. I didn't change anything. I just put an ln instead of an log. Okay, so just so you guys know, A natural log is exactly the same as an log with a base of e. Those two things are exactly equivalent. Right. Yeah, so it's like the shortcut. Not that it's a giant shortcut by any means, but nonetheless a shortcut. So they're going to ask you to evaluate natural log. So if I ask you to evaluate the natural log of 32, how'd you do that? Sure, you could. You mean a exponential function? Is that what you mean? Because it technically is a log. It's a natural log. You could do it that way. So you could totally say, okay, this is equal to x, and go e to some x is equal to 32.
So if you said that natural log of 32 is equal to y, then it would be the y. Right?
Wait, say that one more time.
So when you're evaluating that, you put natural log of 32 equal to x. You said equal to x.
Yep.
You said it equal to y instead. Either the y equals 32.
Yep. You can use whichever variable you want. We could use z, we could use w, whatever. Yep. Anybody come up with an answer? Did anybody happen to just type in natural log of 32 in the calculator? That's what I would have done too. Yeah, so I would just type it in the calculator. So what was it again? 3.47. Okay, let's round to 3 decimal places. So I need a 6 here instead. 6 what? 466. Perfect. All right, so let's just make a quick blanket statement. We're going to round to, as soon as this catches up with me, 3 decimal places. If there's a decimal involved, we're rounding to 3. Come on. Let's throw this one out. E to the natural log of 4. Why is it 4? Because it cancels out, right? The base cancels out because they're the same. So natural log properties are the same as the regular properties. Right? Okay. Why would you what? Natural log of 4 and do what? Natural log of 4. Oh, are you converting it into not log form?
I lost it.
You could type that literally into your calculator. You could type e to the natural log of 4 in your calculator. Or you could use the fourth property and say, oh, the base is the same as the base of natural log, so it just cancels out. Right? Okay, so the bottom line of that is that all these properties that we've been talking about apply to natural logs.
Good.
Okay. Okay. So part 2 of this is graphing. So did you guys think that graphing was exponential of graphing? Did you guys think graphing exponential functions was hard?
No.
Okay, then logs is not much different. It just has a different look. Okay, so remember at the very beginning of this, and probably more than once already I've said, logs are what? The inverse of exponential functions. Okay, let's talk about a very basic exponential function. Let's do something like 2 to the x. Very simple, very basic. Okay, how do I graph that? What's my y-intercept? 1, right? Because it's invisible, so it's 1, it's in front. And then the 2 tells me it's a growth. So I basically just draw this growth that goes like that, right? So there is an asymptote. Where is my asymptote, by the way? Okay, so I have a horizontal asymptote at y equals 0. And that's important to understand. Okay? All right, so when we did inverses, we did this early in the year. I'm sure you remember. Do you guys remember what happened graphically with inverses? Do you remember how we found them algebraically? No. That was the notation, though. You switch the x and the y, and then you solve for y, so that's how you find an inverse. So graphically what happened was the original function is reflected over the y equals x line. Okay, so if I draw the y equals x line, okay, so that's y equals x, and I take that blue function and I reflect it over that black line. What is it going to look like? What does a log function look like? So you see that reference point that I drew? The y-intercept? Where is it now going to become? There is. Yeah. So we're going to now have that reference point exist exactly on the x-axis. Okay, I'm now going to have a vertical asymptote at x equals 0. Okay, and so my function is going to ride this asymptote and curl up and to the right. That's a log. So the red one is a log. So the equation of this log, what's the equation? What's the base? Log base 2 of x. So if you type that into your calculator, the log base 2 of x, assuming you know how to do that, that's what you would see.
How do you do?
I'm not going to go over that right now.
If you remember.
If you remember from last year. Okay, so all of those translations, we're just going to take those and move our logs around. A natural log? The natural log of x would almost look exactly the same as that, but actually it would be really, really close to that, but the slope would be just slightly steeper. It would almost be identical because the base of a natural log is 2.718, which is e, exactly. So it would just be slightly more sloped. Right. It'd be a little steeper, yeah.
I got it.
Mm-hmm. And I'm not going to be looking at the steepness of your stuff. I'll just be looking for asymptotes and reference points. Okay. So, for this first question, if I have a +4 inside parentheses, what direction does a +4 inside parentheses move any function? To the left. Okay, so that means I'm going to take this function and move it to the left. So what happened specifically with my logarithmic function? What's the first thing that I want to think about?
Oh, make it break.
No. I want to think about, so I'm thinking about this red piece, right? Just the red. And I'm not even going to think about the exponential piece anymore. I'm just going to use the red piece to help me move this with translations. Okay? So just a quick blanket statement about the base. Okay? First of all, what is the base of this? 10. Is 10 a growth or decay? Growth. Okay? So ideally, I'm still drawing that up and to the right. So the base only affects the way it looks, just like a growth does. Okay, so if I ever had a base that was less than 1, then that would be the opposite of the decay piece. Okay, which you won't see. They don't ever do that, so don't worry about that. Okay, so it's going to go up and to the right. Okay, so if I move to the left, what is going to shift to the left? The first thing that I always draw. That dotted line. Oh, you did?
Yeah.
The vertical asymptote? Oh, I didn't hear that.
Oh, I said what I meant.
Oh, okay. So the first thing I always want to draw is that vertical asymptote because that helps me draw things. Okay, now where is my reference point going to be? One. It's always going to be 1 unit to the right. Always.
No matter what.
Always. The only way you can change it is if it was reflected over the y-axis and it's on the left side. Otherwise, it will always be 1 unit to the right.
No, it's always.
Just always is. I just told you. That's how I know. Because if you were going to convert that into exponential form,
So you need the x y line, and you flip it over that. That's what makes it a log function.
right? That's where I came up with the parent function. So I took the red function that I drew up here, and I'm using that as my parent function.
So that y equals
Now I'm
x.
just shifting it around.
That y equals x line. That's going to shift with.
No, don't think of it that way. Don't think of it that way. So, okay. The whole reason why I did this at the very beginning is just so you know what a logarithmic function looks like. Like if I say, what does x squared look like? You go, oh, it's a parabola, right? If I say x cubed, it's a John Travolta. Okay, well, if I say, what does a log function look like? Now you can say, oh, it has a vertical asymptote and it goes up and to the right. Okay, so that's just the parent function of a logarithmic function. And now all they're going to ask you to do is do the translations of that. So move it up, down, left, right, possibly reflect it upside down. And that's about it. It's not going to get super complicated. Okay, so should I do one more? Like as complicated as I can imagine? Actually, let me do two. Let me do one slightly more complicated and then the super, super complicated one. Okay, let's say we have 3 natural logs of x minus 2 plus 4. That's pretty complicated. That has a lot of translations in it. Okay, what does the plus 4 do? It makes it go up 4, so that little reference point is going to go up 4 units. What does the minus 2 on the inside of the parentheses do? Vertical asymptote, what direction? To the right 2. What does the 3 up front of any function do? It's just a slope change. It makes it steeper. Okay. So I'm going to draw my log function. I'm going to start by drawing the vertical asymptote. Where is my vertical asymptote? To the right 2. Dot, 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 dot. Now all I want is my reference point. Where is my reference point? To the right 1 and up 4. There's my reference point. All I'm going to do is draw my log function. It does have a slope of 3, so I can go a little bit steeper on it if I so choose, but really it's going to be hard to tell. on what you draw. A negative, potentially, but you would just draw it upside down. So if it was a negative out front, you would do the same thing, everything would be exactly the same, but when you went to draw it, you'd start up high and curl down low. No. Because the difference between a decay and a logarithmic function, so remember decays have horizontal asymptotes. Okay, so a decay would come up high and go down and level out in the end. Whereas if it was a negative log, it would start at a vertical asymptote and curl down. So they, when you're zoomed in close, they do look very similar. But if you zoomed out, they would look very different. Okay, here's my big do you really got it one. Okay, so see if we can figure this out. So first of all, if I have minus 2, what direction does that go? Down 2. Down 2. Plus 3 on the inside? Left 2. What the heck do I do with this 1/4? Oh, 3, sorry. Yeah, 3. Thank you.
Well, it's going to be 2 eventually, right?
It's going to be what?
It's going to be left 2 because you got your reference point is going to be right.
No, I want to stay with 3. It will never go through 2 because it goes up and to the right. My reference point will be at 4. Or no, sorry, left. No, okay. Negative 2. It'll eventually go through it. See if I can confuse you some more. Okay, now what does this one look like if it has a base of 1/4? Okay, so imagine the exponential decay looks like this, right? Okay, and if I took that and reflected over the axis of symmetry, so this reference point, what does it look like? It's hard to imagine, isn't it? Okay, so remember you have pieces of information. Let me draw it in red. Okay, you have a reference point that's reflected, so that reference point is still going to be on the x-axis. Okay, the horizontal asymptote then becomes vertical, so you have a vertical asymptote at 0. So, hold on, I have to visualize this. There we go. That's pretty good. What does that look like to you? This is what it looks like to me. Where was that negative we did? Oh, I didn't ever draw it. I never drew a visible. But what it looks like to me is if it was, remember when we were talking about the negative version of this, if I had a negative out front? That's what it looks like.
Wait, which one?
So the red one. So I'm drawing the red one now. Okay, so what's the first thing I draw of my function? What's my vertical asymptote at? So 1, 2, 3. Where's my reference point? Right 1 and down 2. Okay, so then I just draw that red line that I drew before. Down low. So it starts high and goes down low. I might write that in your notes too, when it has a base of less than 1. It's probably a good thing to have in there. Oh, can you ever have a negative base? That's a good question. Is it possible to have a negative base? No. You just can't have a negative base. The function never exists on the left side. So you can never have a negative base.
That's like negative x or like negative 4x.
Okay.
Yeah.
Yeah, you can't have a negative base because, let me think, how can I explain this? So if we thought about negative 2 to the 4th power, no, I don't feel like this is going to be a good example. You just can't. But some people are okay with that and some people aren't. So what is that, 16? Hold on, I'm going to explain that, but just give me a minute. I'm going to think about that so I can explain it why. But while I'm figuring that out, your assignment. What? Say that one more time. I didn't hear what you said. Base. Okay, yes. Sorry. Thank you. I didn't hear you. Okay, so there's your problems.